Section 1.6 deals with functions. Functions can be a very challenging concept, and so I'm going to use a picture to try and teach you what a function is. And if you'd like to draw my picture, that'd be great. I have an archer here and a target, and you all understand archery and how it works. But to relate it to math, let's talk about the arrows the archer shoots. And I want you to relate each individual arrow as being a different value or number for x. And I would like you to think of y as any spot on the target. So keep in mind that x stands for each arrow and y stands for any spot on the target. Now, what I'm going to do is I'm going to draw a black arrow in here. And let's just give the arrow, let's say that arrow is number 1. Our archer shoots the arrow, and it lands on the target right there, and that's the value 2. So we would have an ordered pair of 1, 2, x being 1, y being 2. Now, let's say that our archer decides to shoot a different arrow. Let's say he shoots a green arrow now. And let's give that green arrow the value 3. Is it possible for that green arrow to land on the exact same spot that our black arrow landed? And any of you that have watched Robin Hood would say the answer to that is yes. It is possible for our archer to shoot his arrow and have it land right in the same spot and have a value of 2. So I have a coordinate of 3, 2. Finally, our archer is going to shoot a blue arrow. And I'm going to erase this number 1 just so I can draw my blue arrow right here. And let's say that my archer, or my blue arrow, has a value of 4. And it shoots and it lands on the target right there, which is a value of 3. What I have here is an example of a function. Yes, this is a function. The reason this is a function is because each different x value, which I'm underlying in red, each different x value has a different or unique y value. And I know that's hard to understand from my picture and what I drew. But if you've got 3 different arrows or 3 different x values, they can hit the target in different places. Now, I'm going to go back and I'm going to erase some of these. And I'm going to go back and I'm going to start over. Okay. Now I'm going to give you an example of something that is not a function. This is a very, very important one. X equals the arrow, and y equals any spot on the target. Same thing. Now, here's my question to you. Is it possible for our archer to shoot a black arrow, and let's say this arrow is numbered, let's say it's got an x value of 1. Is it possible for this arrow to land on the target there and at the same time land there? So is it possible for x to have a value of 1 and end up at 2 and at 3, one arrow at the same time? Well, obviously we all know that one arrow at the same time cannot end up at 2 different spots on the target. This is physically impossible. Well, in math, it is physically impossible for the same x value to go to 2 different y values. It is not possible for one x value to go to 2 different y values. Therefore, this particular example is an example of something that is not a math function. This is something that is impossible and cannot be done on your graphing calculator, and it is something that breaks all the rules of high school mathematics. You cannot have one input value produce two different output values. Now, let's apply that to a mapping. Here's an example of two different mappings. Here's example number 1 over here, and here's example 2 over here. The question, are either of these a function? Well, if you keep in mind what I just mentioned, one x value can't have two different y values. And that's what I'm looking for. I'm looking for, do we have any of these situations? Well, if you look at example 1, the number 2 in the x column only goes to one value of y. The number 4 only goes to one value of y. Even though it's the same number, that's okay. And the number 6 only goes to one value of y. Therefore, yes, this is a function. However, example 2, the number 2 goes to one value of y. That's okay. However, our major difficulty is the number 4 because it goes to both the number 1 and it goes to the number 3. This represents something that is not a function because this number 4 cannot have two separate y values. Now, let's look at those mappings as a graph. I've got the same exact two mappings here, and I want to talk about as a graph what is a function and what is not. Now, if I plot, I'm going to do example number 1 right here. Let's plot these points. So I have the point 2, 1, which is right there. I have the point 4, 1, which is right there. And I have the point 6, 3, which is right there. Now, this is an example of a function. And the reason why and how I can tell is because if I draw vertical lines through that graph, they all only touch the graph in one spot. So this is a function. Now, from before, here's our mapping we know that doesn't work because of the 4. But if I plot these points, I have the point 2, 1, which is right there. I have the point 4, 1, which is right there. But I also have 4, 3, which is right above it. And then I have the point 6, 3. Now, if I connect those, this is an example of a graph that is not a function. And how can you tell? Well, if you're presented with a graph, you can tell because if you can find one vertical line that touches the graph in more than one spot, right there is our problem. Because of that 4, I have 2 dots on the graph that are on the same vertical line. This is an example of something that is bad. This is bad mathematics, and therefore it is not a function. Finally, I present you with 2 graphs. I'd like to know which graph is an example of a function and which one is not. I hope you all chose the second one. I can draw one vertical line, and if you notice, it touches the graph actually in 3 spots. Therefore, this is not a function. The first one is because every vertical line that I draw will only intersect the graph in one spot. One spot there, 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 etc. So this is a function. Excuse me, this is a function. And that is how you tell when you have a graph if you have a function or not. And I'll summarize it in words so you can write it down. It is called the vertical line test. A graph represents a function. Please write this in your notes. A graph represents a function if every vertical line, I think I spelled vertical wrong up here, I apologize, we'll rewrite that. Vertical. There we go. A graph represents a vertical, or a graph represents a function if every vertical line intersects the graph in exactly one spot. In order for it not to be a function, all you have to do is find one vertical line that strikes the graph in 2 or more spots. And there you go. And that's the summary of what a function is in mathematics. And I talked to you about how to represent that. If you need to hit pause, please hit pause to copy that down. But I'm going to go back here. Let's see, we're going to go back. And here's, again, the example of not a function. And this is how you tell from a graph. You draw those vertical lines. And this is how you tell from a mapping by looking at a mapping or a set of ordered pairs. If you can find one x value that goes to 2 different y values. And that's the lesson on functions. Hopefully you copied that down. And please, if you have any questions, please ask me in class when we discuss this